Hello everyone, this is Junaid here from Edureka and I welcome you all to this interesting session where we are going to color old images. So without any further ado, let me quickly walk you through today's agenda. We'll start this session by understanding the problem statement and the common workflow that goes along with it. Moving ahead, I'll be talking about the tools and frameworks that I'll be using, and finally we'll end this session by taking a hands-on demo on working on this particular project. Guys, before we begin, do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you're someone who's looking forward for deep learning certification using TensorFlow, please check out the link given in the description box below. Alright, so coming back to our project, here we'll be provided with various types of images belonging to different classes. Okay, we'll be making use of encoder-decoder model, which is actually an advanced version of a CNN architecture. If you don't know what is encoder decoder, here basically you're trying to use convolution neural networks, and at the same time we are going to use the transpose of the convolution neural network. And then if you're someone who's totally new to encoder decoder in neural networks, I would provide the link for that in the description box below. Well, now you might be wondering, right, what is the common workflow over here, right? Well, with respect to this machine learning or deep learning project, the workflow usually remains the same, right? Initially, we would try to collect the data. Here, for this project, I've collected the data from Kaggle and uploaded my data set to my OneDrive. Okay, and then once we have our data, all we need to do is pre-process the images. If you're someone who's working with pre-trained model, then we have a built-in functions that would be taken care of it. Apart from that, if you're trying to create your own model, then all you need to do is create a function wherein we can perform pre-processing of our image, like image thresholding, and then like normalizing our image and various other parameters that goes along with it. There's an important thing that I would like to mention over here. When you're trying to work with deep learning model, make sure you keep a constant image size. All right, so the image size that I would be working over here would be somewhere around 255, and we are going to normalize the image by dividing all the pixel values by 255. Okay, so once we have pre-processed our images, all we're going to do over here is create an encoder decoder architecture and train our images based on the different classes. Now whenever I try to pass an image, let's say black and white image or any gray image into my model, based on the whatever objects that are present, right, the images get painted up automatically. Alright, so this is all there is about workflow of our project. So let us now move ahead and see what are the various frameworks that we are going to use over here. So first off, the library or the IDE that I'm going to use is my Google Colab. Okay, as we all know, a Google Colab provide me with a built-in GPU, so it becomes pretty easier and faster to train my models. Apart from that, couple of frameworks that I'm going to use here would be NumPy, Matplotlib, sklearn, and obviously the deep learning framework that is there, that is TensorFlow. Mostly I would be using Keras for most of the applications here. Alright, so now that we know what we are working with over here, let me now quickly jump to my code editor and show you how we can build a machine learning project where we can color our old images. Alright guys, as I mentioned earlier, the dataset I have uploaded that to my Dropbox, and let me just copy that link for that. Okay, this is basically a Linux command, wget, and all I need to do is provide the link of my Dropbox. Let me give a comment here, import my data. Okay, and let's execute this, but before that let me change the runtime to GPU and let me save this up. Let's execute this just so that we can get our data set now. So as you can see here, we have got our images, and some of the whatever the images were there in the zip file are getting unzipped, and we can see them over here, right? So we have images, training set, and validation set. And these are the different classes of the image that we can use. And similarly for the validation, we can use this over here. Okay, so now that we are done importing our data, what I'm going to do is let me import some libraries. So first off, I'm going to import pandas as PD, then I'll import NumPy as NP, then the other one is import Matplotlib. Then apart from that, I'll also import shuttle. This would help me to move my file from one folder to the other. Okay, and apart from that, we have, let's import OS. Using OS, I can deal with the path. And in order to read our image, although I can use Matplotlib, we also have some libraries, that is like from skimage.color import RGB to lab. Okay, and the other one is lab to RGB. All right, so if you're someone who's wondering what exactly is this lab, right? Well, lab is just like an RGB color scheme. Okay, and here L over here stands for something like lightness. Okay, and then we have A has typically values which is red in one end to the green in the other end, and then we have B, right? So B basically has yellow on the top and blue on the bottom. Okay, and in order to convert, right, in order to create or in order to work with our images here, we are going to convert our RGB image into lab. All right, and we'll also import from skimage.io import imread and imshow. All right, so let me now execute this. This looks great. And moving ahead, now all I'm going to do is, create a path. Let's say train root directory, and we'll give a path name over here. We will set the path to this part here, training set, right? So let me copy this path and paste it here. And also I'm going to put this or transfer the images here to a particular destination, dest, and we give this space over here, and let's say train images, right? So we'll have train slash, the folder name would be images. Okay, and now we are going to create this folder. So creating a folder is pretty simple. First off, we want to see if the folder is already existing or not. So for that, if not os.path.exist, I'm just going to give destination. All right, that is if this particular folder is present or not, train folder. If the folder is not present, then please create the folder, that is os.makedir, make multiple directories, and then we'll give the name here as destination. All right, so now moving ahead, we'll iterate this over here for dir in os.listdir. Listdir would give me the list of objects, listdir, and all I need to do is, take the images from here, training set, right? That is over here. So let me copy this. We have various formats here, drawing, engraving, and all of that. So let me add this up over here. Go through each of these class, and then another for loop for image in os.listdir, where I'll have os.path.join. We will just pass here a training root directory, that is train. Okay, let me just copy this from here. Okay, what this os path.join does, if I go for this, so far it's still here. Okay, training set. Now what I want is I want to enter into my drawings. Okay, just so that once I enter into my drawings, I can look into all the images that I have. So as I have mentioned earlier, if I want to know what is present inside my directory, all I need to do is list dir, right? So similarly, I'll just pass the directory name here. So this would be dir. Okay, dir represents drawing, engraving, icons, painting, and sculpture. This looks great. And now finally, we'll just create one variable, temporary variable, like let's say origin or source, os.path.join. We are going to take the entire image. So this would be train root dir with the name of the class and the image name. And finally, destination. This would be the train images, right? So we have already mentioned the destination here. All right, so sometimes what happens is, few of the images can't be read, right? And if we try to train them, we'll get an error when we're trying to, work with our models. So we'll fix that right over here. So what we'll do is we'll try to read our image. So imread, read the image which is present in origin. Okay, if it is able to read, then please copy it, like shuttle.copy. Fine, and just move your image from origin to destination. All right, and by any chance, if the image doesn't work, right, so I can just use except, and let's say something like print. Let's say if that particular image isn't, it's not able to read, the image art cannot be read. All right, and here all I'm going to do is pass the path. It's going to be origin. This looks great. If you want me to give you a quick summary, we are just trying to access this. We are trying to have a dictionary here. This is going to be train root directory, and this is the place where we are going to create a small little directory over here. So first off, we'll see if the image, if the directory isn't present. So first off, create this directory with the name train, and then inside that images, and then load all the images present in the train dataset to our dataset present over here. And also, just to be on a safer side, we'll only load that dataset which we are able to read, and if the dataset is unable to be read, and we're just going to throw an error over here. So let me execute this now. All right, so this is a small mistake that we have done. All we need to do is st, and now it's set to go. So as you can see here, there are a couple of images that cannot be read, and if we were to train our model using these images, this would definitely throw us an error. All right, so now we are done getting our training data set. Let me give a comment here. Okay, and now let's do one thing. Let's see how many images we have in our training class over here. Okay, so if you want to see how many class we have, all you need to do is length. Okay, and we all know that if I use os.listdir and then pass the path, that is the path of our image. Let me copy my path here. So let's see how many images we have. So as you can see, we have 7,721 images to train our model. All right, so now that we are done working with our training data set, what we'll do is, similarly we are supposed to work on a validation, but as of now what we are going to do, we are going to create a function called as training data generator, and then we'll pass this training data generator to our function over there. Okay, so let me quickly get that done. Training data generator, let's me call it as train data gen. Okay, so for this is going to be image data generator, and to use image data generator we have to use a keras library. So from keras dot preprocessing dot images import image data generator. Let's execute this up, and now let's call our image data generator. Let me minimize this, and we'll say here as image data generator, and this takes in a couple of values. Okay, first off we have to rescale our image, that is to normalize our image. Rescale, we'll give it as 1/255. Okay, then color mode, we'll give it as none. Okay, and then let's try doing some image augmentation. So with this we can get more dimensions, right? So then we have feature wise center, we'll give it as true, and then rotation range we'll give as 40, and finally we have horizontal flip, we'll give horizontal flip as true, and one last parameter is feature wise standard normalization. Okay, and we'll give it as true here. All right, and let me bring all of these into a place where we can all see this. Color mode, feature center, rotation, horizontal flip, feature standard normalization. As we are trying to use this, what we are going to do is let's try not to use this now, and let's see if we are not getting an appropriate results, we can then work on rescaling it up. Okay, and let me just add this over here and bring this to an alignment. Okay, so now we have done this, so we'll give here as train, and this would be data generator dot flow from directory. Okay, and all you need to do is provide the path here, directory path. So our directory path is going to be images. Let's copy this. Okay, apart from that we need target size, so make sure target size will remain the same throughout your project. So the target size I'm going to use here is going to be 256, so it'll be 256 comma 256. Then we'll also take batch size, as we have 7,000 images, right? So let's take batch size as 250 images. You can also make it as 251, and then we'll give here a shuffle is equal to true. This would increase the randomness, right? All right, so let me align this up exactly like this, and let me put this over here, and let's execute this. Okay, so as you can see here, it says found 0 images belonging to 0 classes, right? Well, yeah, we have done a mistake here. Instead of going here for images, all we'll do is we'll just go for train and execute this. You will see here it came down to 7,721 images, right? remove this for now, and this would still remain the same. All right, so now if you're someone, right, you would have a question, how does my image looks like, right? So now to visualize our image, so to visualize the image, we have something like train.next. So let me quickly show you how that works to visualize the images. So first off, I'll give it as t image and then label, and then all you need to do is train.next. All right, so now if you're someone who is looking forward to plot this image, we can write this function here, def plot image. This takes in image array and then a label. Label is optional, but it's fine. I would like to give a comment over here. Let's say this takes in image arrays and then output plots the image. All right, so what I'm going to do here is plt.figure, let's say figure size 5,5. So from image, and then we also have L in zip image array comma label. So let's now finally plot this up. So for, right, for, let's plot this up. plt.imshow image, and then plt.title im.shape, that is the shape of our image. We'll also keep our axis off, plt.axis off, and finally plt.show. All right, this looks great. Now all we need to do is pass this image over here, right? So plot images, and now let's put here t image and then label. All right, so now if I try to run this part over here, right, all the images would get printed out, and this would take me a lot of time. Okay, so let me show you what I mean. So now if I say t image dot shape, okay, so as you can see here, we have given a batch size as 500, right? So all the 500 images would get printed out. Instead of printing out all the 500 images, let's say I just needed 10 images, right? I just need 10 images from the start, and let's try to execute this. Okay, let me take from starting to 10. Okay, so as you can see, now we have changed the batch size to 10. All right, so now what we'll do here, similar to this, we'll just take 10 image, copy and paste this over here, and similarly it goes with the label. Let's see how label looks like. All right, so label is fine. All we need to do is for the label, we just need the first 10, and now it's ready to run. Okay, so as you can see here, we have done some pre-processing. Okay, but you know, as you can see, our data, the images over here are not that accurate, right? So in order to fix this, there's the only one solution. We have to rescale it over here. Just divide your image by 255, and I would remove this part over here. Yes, we're supposed to pass a comma here, and then we have this. Let's plot our image and let's see how it would look like now. So as you can see here now, right, we are getting better images. All right, and also you can see the dimensions of all our images are the same. Now if you're someone who is wondering why are we getting this tilted images, the reason for this is because we had tried to do image augmentation. Although I don't think image augmentation would be necessary, the reason is because we have tried over here, you know, we're just trying to color the images, so image augmentation won't be necessary over here. All right, so now that you have seen how our images or how our data set looks like, let's now move ahead and let's see what we can do with the model. But before we move ahead with the model, right, we have to change our color scale, right? We have uploaded all of this into RGB. All right, and now we have to change from RGB to something called as LAB, which we have discussed earlier. Okay, so for this, what I'm going to do is for image in t image. All right, so we'll have try. First off, we'll have lab. This would be equal to RGB to lab. We have imported this function, right? So RGB to lab. Just pass the image. Okay, and then before this, let's also create this over here. We'll create value like this: x is equal to this way, and then we also have y is equal to this. So now what's going to happen here? We are going to convert this, and our X over here is gonna be X dot append. We're supposed to train our image, right? So this would just be a black and white image. So lab, all rows, all column, and the 0th one. And then finally, this would be our output one over here. So let me run this. And then this is a dependent feature, y dot append lab, all the features. Basically, the y contains the color images, okay? And this is just going to be black and white. And then 1 colon all. We'll try to normalize this by 128. All right. And now if there's an error, so it will be except print error. Okay. So let's now execute this. Okay, so we are getting an error here. Let me quickly see where we are going wrong. Okay, so the place where we are going wrong is that, this should be uppercase because we have defined an array here. And let's now execute this. All right, so hopefully we should not get any error now. Looks great, right? So fine. So now all we are going to do is convert this X into our numpy array. So we'll say X train np.array, and we're going to pass X. And similarly, we need a Y value, right? So Y train is equal to np.array of Y. But before that, we also have supposed to expand the dimensions. So x.train. What does this expanded dimension mean? It means the batch size. Okay. np.expand dimensions. I want it for the X train. Okay. And axis is equal to length. That is at the last, right? So X train dot shape. Let's execute this. And now if you're someone who is super curious about how this would look like, let's say X train dot shape, and then we have Y train dot shape. This is the batch size of the image, and 1 here represents the channel. So the channel number is 1, and the reason why we have 2 is because we have 2 channels over here. Okay, and let me just print this over here. Fine. So we are done pre-processing our image. Now it's time to build our model, right? So let me give a text here. Build our encoder decoder model. Okay, you can also refer to it as autoencoders. So for this, we have a couple of libraries that we have to import. So first off, from keras. Okay, so it's going to be keras.layers import con2d. Okay, and then we have maxpull 2d. Okay, and then we have upsampling. This would basically, increase the dimension by the double of it. Then input, and then we'll also import our activation function, that is leaky relu. Apart from that, we have from keras.models import sequential. Okay, and let's execute this up. Fine. So let's get back now to the code. Okay, building an encoder decoder model is fairly simple. As I've already built this model, I'll just copy paste that up, and then I'll walk you through what exactly is happening here. All right, so as you can see here, first off, we are going to have a sequential model. Sequential model basically means that model is executing one after the other. The input shape that we are giving here is 256, 256, 1. That is single channel, right? And then we are going to pass this off to the convolution layer, and this would keep on going. This is basically an encoder model. And as we go down, we are going to decrease the size of our model here. And once we reach to a certain threshold, right, we are going to start increasing the model shape. So as you can see, it was 256, and now we start increasing it up. Okay, 128, and now once I perform upsampling of this would become 256. And similarly, this is what happens over here. With every time I do upsampling, the size of it that gets doubled. Okay, it's important thing to note over here is that at the end you are supposed to pass 2 over here. The reason why we are putting 2 is because that's the expected output. So let me quickly show you what I mean over here. If I try to execute this again, so as you can see here, this is my Y and this is my X parameter, and we should match up with this. Okay, and as the final value over here is 2, or the number of channels we have 2, that's why we are having 2 over here. And let me now execute this. Once we go through the summary, you'll get to know what's happening here. So as you can see here, initially we have 128, 128, 64, 64. It keeps decreasing, right? 32, 32, 32. And now we are supposed to do the upsampling. Okay, or you can say con2D inverse. But this is not necessary to do the transpose of con2D. We have upsampling for that. And after a certain threshold, like after 32, we are trying to upsample it to our original shape, that is 256, 256, 2. And none over here represents the batch size. And now finally, let's try to compile our model. So it will be model.compile. Okay, optimizer. This is the Adam. Metrics. This will pass here as accuracy. Okay, and loss. This is gonna be mean square error. So you can do like MSE mean square error. All right, and let's now execute this. And finally, we are supposed to train our model. So for this, we'll have HIS history. There will be model.fit. Okay, this will be xtrain, ytrain. The number of epochs that I'm going to train this is, let's say, 50. Or we can go even more. For now, let's go for 50. I've put here 100. You know, it's totally up to you. Whatever accuracy you're getting, it's totally fine with that. And then we'll give here batch size. We'll give batch size as 32. You can also give 64, totally up to you. So I'll give here as 64. So then we'll have to give steps per epoch. Okay, so this is pretty simple calculation. So it's going to be xtrain.shape. That is the batch size. Divide that by your batch size over here. That is 64. And finally, we'll give verbose is equal to 1. Okay, let's do one thing. In our batch, right, we have just 500 images. So instead of 500, why don't we increase this to some more, right? So instead of 500, let's give it as 2000. Because we have a lot of images, right? Why not give it as 5000? Let's try executing this from start. Okay, so this function, every time I run it, I would get to know what are the images that are there. And now we are over here, all we are trying to do is convert it from RGB to lab. And over here, lab would be independent feature, and Y would be, or the RGB, or the two channels which are there, would be our dependent features. Let's try executing this and test our model. The reason why this is taking a lot of time now is because earlier we just had 500 images, and now we have somewhere around 5000 images, right? So that's the reason why it's taking quite some time. So as you can see here, we have a couple of images. And now let's try to convert our image to a different format. All right, so as you can see here, the Colab has crashed. The reason for this is because we have given a very huge batch size. So let's try fixing that up, and let's keep it to, you know, rather than 5000, let's try keeping this to 1000, okay, or 1500. Let's execute this. Okay, it looks like we're supposed to run this from the start. So let me do run all, and let's wait for it to train the model. Okay. Alright guys, so as you can see here, I tried to restart my kernel over here, and now my model has started to train. Let's see how the accuracy would look like. Okay. Alright guys, so as you can see here, we have started training our model. Alright, so let's see how this would look like. Okay. Alright guys, so as you can see here, we have successfully trained our model. Our accuracy has somewhere, you know, come down to 95, and somewhere there was around 80 as well. Okay, so now what we're gonna do is we will just try to save our model. Let's say here, and let's say model.save. And this would make sure you always give this extension as H5, right? So best model.H5. Okay, and now if I try to save this, give a couple of seconds, and you will see we have .H5 file here. All right, so this is great. So now what we're going to do, let's take some image, black and white image, and let's see whether we can color the image or not. Okay, so we'll have image, let's say image 1 underscore color. We'll put this in an array now. Okay, and now we have this function img is equal to image to array. Okay, in order to use image to array, we have this built-in function that is from using keras. Let me scroll up completely here, close this. Okay, so we have to import image to array. And then we can also import load images. And let's execute this. And we'll come down here and let's say image path, and we'll give this as a string. Meanwhile, what we'll do is we'll create an image to array. All right, and we'll pass here a function called as load image. Okay, and this is where we give the path. And apart from that, we have to mention the target size. So obviously the target size will be 256, 256, 3. And make sure you normalize this by dividing it by 255. Okay, so sometimes we do get confused by adding it over here, but make sure you add it to your image array. All right, so now that we are done, let's also see how this would look like. So we'll have plt.title input image, then image.show, or you can just use show image, right? Show the image because it's in the form of an array. Then we'll turn off the access, plt.access, this should be off, and finally plt.show. Okay, so now what we'll do is we'll get down to the Google here. Let's take any black and white image. Let's take any random image, something that has grayscale, right? So okay, this looks great. So we'll take any of this image over here from here. Let's try taking this up. Let me save as in my downloads. And now let's try to upload that as well. Okay, let me copy the path for this and let me paste it over here. And let's see if this is working fine. Okay, so we have done this typo over here. Let's fix this up. And now it should work fine. Okay, so this is the black and white image. Now let's try to color this up. But before that, we have to convert this image to lab format. So we have image1 color dot append image. Okay, and now let's say image1 color, this would be equal to RGB to lab, where I'm gonna pass image1 color, in the sense convert this particular image, that's image1 color. Okay, and all I need over here is my lab format. Okay, 0. And now finally we'll do here is image1 color will be equal to image1 color dot reshape image1 color dot shape of 1. Okay, and now what we'll do here is try to predict this out. Okay, so output 1, this would be equal to model dot predict image1 color, and then finally this would be output. We are supposed to multiply this or scale this up by 128 times 128. All right, so finally what we're going to do here is, first off create an numpy array of zeros whose size is something similar to 256, 256, 3. And then at the 0th channel we'll add this output 1, and in the rest of the channels we're just going to add the original image. Okay, so this would look something like this here, and let me execute this up. And finally, if you have to see the image, show lab to RGB, and now finally we have the result. So as you can see here, we have somewhat colored this image, but this is not something that we expected, right? The reason why we are not getting the exact values over here is because we haven't trained this on a huge amount of data. If you are someone who has around 16 GB of RAM on your system and a good graphic cards with a good amount of memory, you can definitely run this on a huge amount of data set, and then you'll obviously have a better results over here. All right, so this is all there is about how you can process any image, any black and white image, and color them up accordingly. All right guys, so now that we are done with the project, now you might be wondering how can you improve this, right? Well, there are a couple of things that you can do here. You can use either tkinter or Kiwi in order to use that as a GUI interface, and then provide any amount of black and white image. Let's say take an image of your grandparents and try to pass it through your model, and make sure you train your model on a very huge amount of data set, just so that you can get a better accuracy on your models. Alright guys, with this we come to the end of our session. I hope you enjoyed and learned something new. If you have any further queries, please do mention them in the comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!